Hello class, today we are going to talk about the properties of parallelograms. And now for most of you, this should be almost entirely review. Most of the stuff you learned way back in middle school or maybe even elementary school. There's a couple things that might be new, probably should be new, but most of this should be review. All right? So before we can talk about properties of parallelograms, we have to know what is a parallelogram, right? Well, a parallelogram, as you remember, this is a quadrilateral with both pairs of opposite sides parallel. Generally, it's drawn, it looks like a rectangle that's kind of fallen over a little bit. Okay? So, here's my pen. There we go. You see, we have opposite sides are parallel. Right? These two are parallel, those two are parallel. Parallelogram, that's why it's called parallelogram, because we've got two sets of parallel sides. All right, so let's talk about a couple of theorems, a couple of properties of parallelograms. Number one, the parallelogram opposite sides theorem. This says that if it's a parallelogram, then the opposite sides are congruent. Not only are the sides parallel, like we saw here, they are also congruent. So, since this is a parallelogram, that means that segment QP is congruent to segment RS, and segment QR is congruent to segment PS. Opposite sides will be congruent. Okay. Next theorem we have is the parallelogram opposite angles theorem. All right. What this says is if it's a parallelogram, then the opposite angles are congruent. Just like opposite sides are congruent, opposite angles are congruent. Okay. So that's easy enough. Next, parallelogram consecutive angles theorem. If it's a parallelogram, then consecutive angles are not congruent. Consecutive angles are going to be supplementary. All right? And this should make perfect sense because if you remember way back ages ago when we were talking about parallel lines, we said that if two lines are parallel, which we know they are because they're parallelogram, then consecutive interior angles or same side interior angles were supplementary. So that means they add up to 180 degrees. All right? So this is just saying, hey, all that stuff we learned back then still applies, and it shows up with parallelograms. Okay, last one. Okay, that you may have known, may not have known. This one is probably going to be new. The parallelogram diagonals theorem. If you have a parallelogram, then the diagonals will bisect each other. They will cut each other in half. And so M is going to be the midpoint both of QS and the midpoint of PR because they both are cut in half. It bisects both of them. All right? And so that is probably new. And this one here might be new. The other three, opposite sides, opposite angles, that you probably already knew, and you should have known the definition. Quadrilateral with opposite sides parallel. All right. So let's take a look at this. Let's do some examples. See what we can do with this. Okay, so exercises 1 through 3. Find the value of each variable in the parallelogram. All right, so looking at number 1, we have some x's and we have a y. All right, so these are all on the sides, which we can do because we know that the opposite sides are going to be parallel. So which one do you want to start with? How about we start with here? Well, that would be 4x equals y, and I'd have two variables. I can't solve for two variables at a time. I can only solve for one, right? So let's do the other two sides. That way I just have x and x. X is the only variable in that, so let's do that. Okay, so they're equal to each other because they're congruent. So 3x minus 2 equals x plus 8. So let's see, first we are going to subtract x from both sides. We're going to add 2 to both sides to cancel the 2's out. And so that gives us 2x on this side and 10 over there. Divide by 2. And we end up with x equals 5. Okay, so that is the first thing we were looking for. We need to find x. Now we have to find y. Well, we still end up with this equals that, 4x equals y. But now I know what x is. So 4x equals y. I know x is 5, so that's 4 times 5 equals y, which means 20 equals y. And now I have both my answers. All right? So that's really not too bad. Pretty simple stuff, really. Okay, so tell you what, how about you do number 2 right here? You know what? How about you can manage 2 and 3? So go ahead, pause the video, work out number 2 and number 3, then come back and see how you did. All right, let's see how you did. Once again, we have x's and y's. Opposite sides are congruent, but I can't do that yet because I don't know what x or y equals. Let's see, this x, I can't set it equal to that x because this one's a side and that one is an angle, but I do have an opposite angle. Opposite angles are congruent, so we can do that. Let's see here. We have 4x minus 37 equals 49. So add 37 to both sides. Plus 37. 4x equals, what is that, 9 and 7 is 6, carry the 1, and that would be 86. Divide by 4, to cancel those out, and we end up with x equals, let's see, 4 goes into 8 twice, 4 goes into 6 once, with 2 left over, so that's going to be 2/4 or 1/2, so 0.5. 21.5. Got decimals. That's all right. Decimals are just another number, not a big deal. Okay, so let's see what we do here. Now I know x, so I can plug x in right there. So we need to solve for y, so I'll put y in the front. Y divided by 5 equals 4 times x minus 3. And I know that x is 21.5. So y over 5 equals 4 times 21.5 minus 3. Alright, so first thing we want to figure out what this equals. So we have y divided by 5 equals 4 times 21.5. Well, that's 86, because that's how I got the 21.5, isn't it? So that's 86 minus 3 is 83. Now we got to get rid of the 5, so we're dividing by 5. We do the opposite. We multiply by 5 on both sides, and y equals 83 times 5, which is 415. And there's our answers there. Hopefully that's what you got. Okay, let's take a look at number 3. Let's see, we have some x's, we have some stuff with y's. They're on diagonals. That's different. These were sides and angles. Here we have diagonals. Is that okay? Can we do stuff with that? Sure. Remember, diagonals theorem, the diagonals are going to be bisected. They're going to bisect each other. So this diagonal cuts that one in half, so that means these two are congruent. And this diagonal cuts that one in half, so these two are congruent. Alright, so let's just do the x's first, because why not? 4x minus 2 equals 2x plus 10. Let's see, move the x's first, so we'll subtract 2x from both sides. Cancels that out. Let's move the 2, so plus 2 on both sides, and that's gone. And now we have 2x equals 12. Divide by 2 on both sides, and x equals 6. And let's do the y's. So what do we have here? Okay, so 3y equals 5y minus 16. Now normally I'd want to move the 3y because it's small, but I don't have any constants here, so I'll just move that y. Minus 5y minus 5y, that gets all my y's over there and nothing else. Negative 2y equals negative 16, divide by negative 2, and I end up with y equals 8. Alright, and hopefully that's what you got for number 3. X is 6, y equals 8. So not too bad, right? Remember, opposite sides are congruent. Opposite sides are congruent. Opposite angles are congruent. And the diagonals cut each other in half, which means both sides of these are congruent. So we're just setting stuff equal to each other. That's not a big deal. Pretty simple stuff. All right, let's take a look at the back of this. Have to be moving stuff up and down and up and down. That's annoying, but whatever. All right, let's see. Find the indicated measure of triangle MNOP. Explain your reasoning. And that's always the hard part, right? Explain. That's all right. We got lots of theorems we can use. So let's see here. We need the length of segment PO. Segment PO is right here. And it does, see here, find the, that says triangle MNOP. That should be a parallelogram. So we'll make it a parallelogram. There you go. All right, parallelograms. We know it's a parallelogram. Typo there. So what does that mean about segment PO? Well, it's going to be congruent to segment MN, right? Opposite sides are congruent. So this is going to equal the same thing that equals, 24. And how do we know? We need to explain. Well, let's see, opposite sides, that's going to be the parallelogram opposite sides theorem. I have to write that out. Parallelogram opposite sides theorem. Theorem. All right. Let's try OQ. Let's see, OQ is right here. It's this little piece. Well, that's half of a diagonal, right? Because it cuts both of them in half. So that means it's going to be congruent to that. So OQ is going to equal 14. How do we know? Because way down here at the bottom, we have the parallelogram diagonals theorem. It says they bisect each other. So parallelogram diagonals theorem. Okay, segment NO. No. All right. Segment NO is right here. What's that going to equal? Yeah, that's right. It's 26. Opposite sides are congruent. So this is going to equal 26. And this is going to be the same reason we had up on number 4. Parallelogram opposite sides theorem. What's the next one? Segment PQ. Where is PQ? There it is, segment PQ. Well, now we're on the diagonal again, right? And as we already saw, we have that theorem there, the diagonals bisect each other. So that means Q is not only the midpoint of MO, it's also the midpoint of PN. So these two sides are congruent. So PQ is going to be the same as QN, and that's going to be 20.7. For the same reason that we had on number 5. Parallelogram. It'd be nice if there was an abbreviation for that. Parallelogram diagonals theorem. Okay, so here we're getting into angles. The measure of angle PMN. Let's see what PMN. PMN. Well, what do we know about the angles of a parallelogram? We know the angles. Here we go. There's some of it. Let's see that. We know that opposite angles are congruent to each other, and we know consecutive angles are supplementary. They add up to 180 degrees. So let's see how we can use that here. We're looking for this angle, PMN. So opposite of PMN, well, we got that 59, but that 59 is just this little piece right here. So that's not what we want. We want the whole thing, right? So we can't use opposite angles. What about consecutive angles? Remember, consecutive means right next to each other. It's the very next one that comes along. So the next angle, well, we don't know that one. So what about this one? 68 degrees. If you'll notice, it's got the mark going across the whole thing like that. That means that this 68 degrees is for the entire angle MNO. All right. So we've got a consecutive angle of 68 degrees. We need to find this one. Consecutive angles are going to be supplementary. So what we can do over here, we can just take 180 minus 68. And so that would be 2, and 7 minus 6 is 1, and 1 minus nothing is 1. So this is going to equal 112 degrees. Because, what's it called? Parallelogram consecutive angles theorem. All right. Parallelogram consecutive angles theorem. All right. Okay, now what do we want? We want the measure of angle NOP. Okay, so now we're getting to it. It's down off the camera. NOP. That would be this one here. Well, again, we know the same thing we knew before. We know it's congruent to the opposite angle, and it is supplementary to the consecutive angle. So, actually, we've got two things we could do now. One, we know it is consecutive to the 68, so I could do that again. Or it is congruent to the angle opposite. It's congruent to angle PMN. I know what PMN is now, because I just figured that out right here, didn't I? It's 112. This is opposite that, so it's going to be congruent. So it's also going to equal 112. So this equals 112 degrees. Why? Because of the, let's get the name right, parallelogram opposite angles theorem. Parallelogram opposite angles theorem. There. All right, let's see. What's the next question down here? Number 10, the measure of angle OPM. The measure of angle OPM. Well, it is going to be congruent to the opposite angle or supplementary to the consecutive angle. Which one's easier? Which one can we use? Well, we do have an opposite angle right here. And we now know that this is a consecutive angle. So we could actually do either one, because we know that this is 112, this one's 112, so we could subtract that from 180. Or we could say, hey, it's opposite 68 degrees, it's 68 degrees. I'll do that one. So this is going to equal 68 degrees. Why? Because of the parallelogram opposite angles theorem. Angles theorem. Okay, last one we want is angle NMO. Let's see, angle NMO. That is not actually the angle of the parallelogram, is it? So, what can we do with that? What do we know about this angle that we're looking at right here? That one. Well, looking at this, we do have this 59. We haven't used that. Maybe that can help us. And if we look at it, those two angles are alternate interior angles, aren't they? Right? If you remember way back when we talked about parallel lines, right? We had alternate interior angles. And we said back then that alternate interior angles were congruent if the lines that were being crossed by that transversal were parallel to each other, right? Are they parallel to each other? Is MN parallel to PO? Yeah, it's a parallelogram, right? That means opposite sides are parallel to each other. So since this is going to be parallel to that, that means that angle POM is congruent to angle NMO, alternate interior angles theorem. All right, so here we go. Let's move this down. What was that? That was 59 degrees. All right, move my paper. It's not behaving. There we go. So this is going to equal 59 degrees. Why? Because of the alternate interior angles theorem. Angles theorem. All right. So that's an old one, something we used ages and ages ago, but it's going to come back and be useful a lot again, because once again, we're dealing with parallel lines inside our parallelograms. All right. So just to recap, properties of parallelograms. Both sets of opposite sides are parallel to each other. Both sets of opposite sides are congruent to each other. Both sets of opposite angles are congruent to each other. All of the consecutive angles are going to add up to 180 degrees. They're supplementary, and that's the angles right next to each other. Those two add up to 180, those two add up to 180, those two add up to 180, those two add up to 180. Each angle is going to add up to 180, is supplementary to the one right next to it. And lastly, the diagonals bisect each other, so they cut each other in half. So the midpoint there is the midpoint of both diagonals. And that is parallelograms. There you go. It's all in one thing. Hopefully you found that useful. I'll see you next time.